In today's lesson, we'll be looking at Theorem 6. Now, Theorem 6 teaches us that the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. Now, let's go and have a look what it means. Here we're given angle A, B, C, and D on the circumference of the circle, which makes this quadrilateral a cyclic quadrilateral because the vertices are on the circumference of the circle. Now, this line of the cyclic quadrilateral DC is extended to E, which forms this exterior angle C1. Now, I just quickly want to show you the following because it's quite important to know that an exterior angle is only formed if one of the sides of the cyclic quadrilateral is extended. So this remains a straight line. This angle, however, is not an exterior angle because this line is not an extension of one of these two. Can you see? It's a brand new line and it's not a straight line from any one of these sides of the quadrilateral. Now today we want to show that angle C1 is equal to angle A. Now how do I know that this is the opposite interior angle for this exterior angle? And I always remember it like this. It's not the angle on the straight line. It's not this angle on the straight line. It's the one up here. Okay, so I hope that helps. So again, not the angle on the straight line, and I continue down the straight line. It's not this one, it's the one up there. Okay, so I hope that helps. Now, we are given cyclic quadrilateral ABCD with DC reduced to E. In other words, this line is extended. Now, we want to prove that angle C1 is equal to angle A, that this exterior angle is equal to the opposite interior angle. Now, here's our proof. We know that angle C1 plus angle C2 is equal to 180 degrees, right? Because it's angles on a straight line. So let's write that down. Angle C1 plus angle C2 is equal to 180 degrees because it's angles on a straight line. Now we also know that A, B, C and D is a cyclic quadrilateral, and we learned before that the opposite angles of a cyclic quadrilateral is equal to 180 degrees. So in other words, angle C2 plus angle A is also 180 degrees. Now let's write that down. Angle A plus angle C2 is equal to 180 degrees because the opposite angles of a cyclic quadrilateral is equal to 180 degrees. Now, C1 plus C2 is 180 and angle A plus C2 is also 180. In other words, angle C1 and angle A has to be equal. So angle A is equal to angle C1. And now, if we have this type of quadrilateral or cyclic quadrilateral with an exterior angle, we know that this exterior angle is equal to the opposite interior angle, and then we use this as our reason, exterior angle of a cyclic quad. Now let's go and look at a quick example. Here we are given the following diagram, and let's go and see what it all means. In the diagram is cyclic quadrilateral ABCD with DC reduced to E. Angle BCE is equal to 98 degrees and we want to calculate angle A. Now, here we go. This angle BCE is 98 degrees. This is the exterior angle for this cyclic quadrilateral. How do we know? Because this side of the cyclic quadrilateral is extended to E, so this remains a straight line. So this is our exterior angle. This angle will be equal to the opposite interior angle, which is angle A. So angle A is 98 degrees, and we can write angle A is equal to 98 degrees because the exterior angle of a cyclic quadrilateral. And there we go. See you again next time. Bye.